guys, my little talkative class. Y'all are the only ones that didn't get to start your notes already yesterday. Okay, so you're a little behind, but it's okay. Okay, so your notes today are not super long. We should hopefully have time to look a little bit at your homework. But they're on continuity. Okay, y'all know what continuous is? In your own words or in the words of whatever your pre-cal teacher told you. What does it mean if a function's continuous? Okay, does it have any breaks in the graph? No asymptotes. You can draw it without picking up your pencil, okay? So all of these are fine definitions. Okay, I'm going to give you a formal definition though.
What I say?
No, you made it, Wilson. Okay, I'm already writing. You should already be writing.
Sit here.
Yeah, Wilson, I almost gave away your seat, and then they said you were coming. I thought you had blood drive.
Hey, hold me back.
Okay. Okay, so technically, one of the things you guys said is a little bit wrong, but a little bit right. If your graph has an asymptote, okay, but it does not continue on the other side, that could count as continuous. So what I mean by that is, y'all know what log looks like? Natural log?
LA.
Thank you. Yeah, so if you have the graph of y equals, let's say, ln x, okay, that graph looks like this, and it has a vertical asymptote here. Technically, could I draw that graph without picking up my pencil? Yeah, because it doesn't continue on the other side. So this actually counts as a continuous graph. So you're only looking at the part of the graph where it exists. Now, what if this graph had stuff on the other side? Then no, I'd have to pick up my pencil to move to the other side. That doesn't count. Okay? So ln x counts as a continuous function, even though it has an asymptote. And the reason why is because I don't have to lift my pencil and keep drawing. When I'm going down on that asymptote, that's the end of the graph, so I don't have to worry about anything else. Okay, so that's kind of like the easy definition. We're going to do a formal definition, and then we're going to prove some questions with it. So your calc definition would be, so put a little star here, f of x is continuous at x equals a if three conditions have to be met. The first one is that you have to have a y value. So we're going to call these little I, okay, like Roman numerals. So f of a has to be defined. There has to be a y value for whatever your x value is. That's step number one. You have to make sure there's a y value. Step number two, you have to make sure that the limit as x approaches a from the left is equal to the limit as x approaches a from the right. So you have to have a y value, you have to have a limit. Those two things have to be true. Now I want you to think about, could you draw a picture where those two things are true, but your graph is still not connected?
Sure.
Yeah? Okay, Nikki, tell us. Huh? Oh. Okay, try to think in your mind of a graph, okay, and then not like a specific function, but like what could it look like where you have a limit and it's defined, but it's not continuous? If it's a hole, good, because what if the hole's in a different spot? Then that's not continuous. So, for example, look at this graph right here. Do I have a y value? Yes. Do I have a limit?
Yes.
Yes. Is it continuous?
No.
No. So the third and most important step is that this y value and this whole have to be the exact same height. So step number 3 is that your limit as x approaches a has to be equal to whatever that y value is. And if this dot is equal to my limit, then it's going to fill in that spot and it makes your graph continuous. Okay?
Yeah, we've seen that a couple of times actually.
Yes, you have. And you're going to see even more. Okay? Yes, so exciting. I think your blood count is a little low. Okay, so question, is f of x continuous at x equals 3 for f of x equals, these are going to be piecewise, x squared minus 5 and x plus 2 less than 3 on one domain, greater than 3 or equal to 3 on the other. Okay, so every single time, if on the AP test they ask you a question like this and it's open-ended, okay, you have to use your formal definition. Okay, we'll use it enough times you won't have to practice memorizing it because you'll just know it. The first one, you check the y value. Now, you are plugging in your value to the part that includes that number. So, for example, if I want f of 3, that's step 1. F of 3, would I plug in top or bottom? Nope, that's for a limit. Bottom. Where do I include 3? Equal to. So, 3 plus 2 is 5. So, I'm going to put f of 3 equals 3 plus 2, which is 5. So, do I have a y value? Check. My y value is 5. Step number 2, this is what you've already seen. Limit from the left and the limit from the right. Okay, and we have already done this. So limit from the left, where would I be plugging in, top or bottom? Left of 3 would be top. 3 squared is 9. 9 minus 5 is 4. So 3 squared minus 5, 9 minus 5, which is 4. Okay, and then my right side, I would be plugging in where? To the bottom, but I already did that. What did I get? I'm going to steal the answer, 5. So my left limit is 4. My right limit is 5. Do I move on to step 3? No, because step 2 said that what? Left and right had to be equal, and they're not. So at this point, you state your conclusion. Condition 1 was met, condition 2 wasn't. Put little 3 dots, you remember therefore from geometry?
No.
Okay, come on. Yes, you do. Therefore, like this?
No, I never did that.
Never? Okay, f is not continuous at x equals 3. So in order for it to be continuous, all 3 conditions have to be true. So once I get to condition 2 and it's not true, I'm done. Answer's no. So you check the y value, you check the limits that they both have to match. We didn't get past there. Ready for the next example? Okay. The 3 dots just means therefore. If you didn't put it on the AP test, nobody would care. But you can feel fancy. Yes?
So it's a condition 1, right? When is it not defined?
We're going to look at an example. Okay? Alright.
Wait, so before, what we're doing is we're just figuring out,
You were only doing the limits.
yeah, and like we would go till 3, right? But then we'll do ODNE.
Mhm.
But now
Yep.
we're talking about.
Now you're doing continuity. So you're checking 3 things instead of just that one thing.
Wow, so it's like all ties up or something.
Yeah, so it's like you just add a little bit extra on top. Okay, so next one. We're going to do a 3-part piecewise. Okay, so f of x is going to be, this is number 2. E to the x plus 4 2x plus 5 and x squared. And we're going to be looking at x less than or equal to 0, 0 less than x less than 3, and x greater than 3. Okay, is f of x continuous at x equals 0 and x equals 3? Now, obviously, we're going to check these values separately. Okay, but if it's multiple choice, I don't care if you follow the definition, but if it's free response, especially for AP, you have to. So, look back at your steps. What's step 1?
Define it.
Has to be defined. So we're going to check 0 first. So I'm going to write x equals 0, and then like a little thing. That's the one we're going to check. So I'm checking f of 0. Where would I plug in? Top, middle, bottom.
Top.
Because it has the equal to.
It's hot.
E to the 0 is 1.
One.
1 plus 4 is 5. E to the 0 plus 4. 1 plus 4, 5. Do I have a y value? Check. Step number 2, I. Captain.
Funny, funny.
Okay. X approaching 0 from the left. Then x approaching 0 from the right. What do they have to come out to be? The same. Doesn't matter what number as long as they match each other. Now, I already plugged into the top. That's my left limit. What did I get? So put a 5 here. We already did that. But now to do 0 from the right, what part am I plugging into?
Middle.
The middle, because this is the other side of 0. That's x when it's greater than 0 but less than 3. So plug in 0 here. 2 times 0 is 0 plus 5 is 5. My left side was 5. So if my left and right limits match, I go on to condition 3. Condition 3, which is I. Okay, your y value and your limit have to match each other. My y value was 5, my limit was 5, so do they match each other? Okay, then you just state that. So f of 0 equals the limit as x approaches 0. Then what's my conclusion? Continuous or not? Yes. So check, check, check. All checks means yes. So dot, dot, dot means therefore f is continuous. What did you say? At 0. Now, we've checked it at 0. It was continuous. Now we need to check it at 3. Okay? As Anusha puts her head into her hands. Okay, x equals 3 will be easy to check. What's step 1?
Define.
Find f of 3. Make sure that it's defined. Where will I plug into my piecewise? You're going to have to look on your paper. Where? Where would you plug in? Nowhere. Where does it have an equal to for 3? Neither part. So is there an f of 3? No. Then what would you put it? Undefined. Okay, so remember, limits are DNE, y values are undefined. Now, I'm going to put a little star here. You can write it or not. Because no part of the domain includes x equals 3. You have an x greater than 3 side, you have an x less than 3 side, but neither of them include an equal to. So if step 1 condition is not met, what's our conclusion? Not continuous. Good. So dot, 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 therefore f is not continuous at x equals 3. So it was continuous at 1, it was not continuous at the other. Okay, we have one more like that. Okay, we're going to put a little trig in it. Are you ready? No? Okay.
What, bro?
Good? That's okay.
Sorry. Hey, Zane, can you put your head down?
Now good? Okay. Alright, third one like that. F of x equals 3 parts is going to be cosine x plus 2. 2x sine x plus 1. X is going to be less than pi halves, equal to pi halves, greater than pi halves. I like to write fast and then just move my hand. Otherwise, my hand ends up blocking parts of everything. I do stick my tongue out when I write. It's weird. I don't know how to stop it. You're looking at my hand going so fast. Okay, so flip back to your notes if you have to. Look at your steps. Check the y value, check the limit, make sure they match.
You plug it into 2x.
Okay, well, we can do it kind of all on your own or together. What would you do first? Plug into 2x because that's where x equals pi halves. Okay, so f of pi halves is 2 times pi halves. Plugging into the middle. 2's cross out, answers what? Pi. Did you get a y value? Check. Aye, Captain. You have to check the limit. Okay, x is approaching pi halves from the left. Then it's going to be approaching pi halves from the right. Now I want you to think about, don't say it out loud, what part you'd plug into. So when it equaled pi halves, I was plugging into the middle. If I want the left limit, you would need to be plugging into less than pi halves, which would be what part? Top, middle, bottom?
Top.
Okay, this is the top. What about from the right?
Bottom.
Bottom. Okay, so plug those in. We're taking pi halves, plugging into cosine. What's the cosine of pi halves? Okay, what is 0 plus 2? So my left side came out to be 2. Now I'm checking my right side. I'm plugging into sine. What is the sine of pi halves? Pi halves is here. All my fingers are on bottom, so that's 1. But then I have to plus 1 afterwards. I get 2. So I have the sine of pi halves plus 1, which is 1 plus 1, which is 2. So question, I had a y value. Do I also have an existing limit?
Yes.
My limit's at 2. Step number 3, these had to match. They don't match, so what would your conclusion be? Not continuous. My limit is at a height of 2, but my closed dot is at 3.14. Those don't match each other, so that would be not continuous. Okay? So, I is that the limit as x approached pi halves did not equal f of pi halves. And if you want to make a little note to yourself, this is where the hole would be in the graph. This is where the closed circle is. And so if those two are not the same, then you know your graph is not going to be continuous. So I'm going to shorthand here and put, therefore, no, not continuous. Okay, and you can write it out if you want to, fine with me. Good? Okay, so what I want you to do is, hopefully we have time to do it plus the rest of your notes. I want you to do number 4 off your homework. So I'm going to give you a second to look at it. You're determining if it's continuous. Then you're going to sketch the graph, which we covered kind of over the last week or so. So number 4 off of the homework you got on your way in. Anybody need it? You'll notice it has a little asterisk next to it. Okay, you're doing number 4 right here. Okay, that one. Yep.
So if we were trying to give you some, like for I, it'd be F1.
It'd be f of the breakpoint, which would be 0.
Oh, there it goes.
Wait, so,
Yeah?
so you know how for every x, so I given us a value of x.
So it'd be your breakpoint. So like here, my breakpoint was 5 halves. That's
So
what
zero.
so it'd be 0. Okay, what is my specific point I'm interested in on number 4? X equals 0. So what should your first thing be?
0.
Okay, I want f of 0. Where will I plug in? Top or bottom? Top. 1 plus 0 squared, what do you get? 1. Do I have a y value? Yes. Step number 2. Limit from the left, limit from the right must equal each other. So, limit from the left, I already did. Thank you, dear. Okay, and we got 1. Okay, limit from the right, we're going to have to think about what would we be plugging into for the limit from the right? Okay, ln, so I'd want the ln of 0, write it down. Okay, now, what do you remember about ln's?
You can cancel it out and make it.
What?
Alright?
No. Okay. Alright, what do you remember about e? Exponential growth. You can sketch it maybe right here. Okay, so, what? Okay. Kobe. E to the x is here. What's this point?
1.
0, 1. Now, what is the relationship between e and ln? They're what? Don't say reciprocals. That's the wrong word. Inverses. Inverses, x and y is backwards, and their graphs are reflected across the diagonal. So if this is e, this is ln. If this is 0, 1, what's this? 1, 0. Now, if I want to know the ln of 0, then I want to know when e's y value is 0, because they're inverses. So if I want ln's x to be 0, I want e's y to be 0. When does e get to a y of 0?
Never.
Never. When does ln get to an x of 0?
Never.
Never. This is not allowed. So it's
Not continuous.
DNE. Don't put undefined because that's the limit. Then from there, my step 2 says these had to match each other. They do not, so therefore, dot, dot, dot. Okay, not continuous. So that is not allowed. I can't take the ln of 0. It's DNE. So it is not continuous. Now, to sketch a graph, you should be able to do that. At 0, where does my closed dot go? What height? What was f of 0? 1. To the left of that point, what's my shape? 1 plus x squared. What's that shape?
Exponent.
Parabola.
Parabola.
Okay, opens up, goes through 1. To the left, it's an ln graph, which we just talked about, goes like that. And it keeps going down forever and ever, but that's the problem. Now, that would be classified as an infinite discontinuity. Even though the sides don't match each other, since one side's an asymptote, you would say it's an infinite. Okay? Great?
Wait, so
Is
ln
it
and
infinite what?
e don't have like a... Because I remember in pre-calc I used to...
They do have a relationship, but so what you would say is the ln of 1 is 0, but the ln of 0 doesn't exist. So the ln of 1 is 0, but the ln of 0 is nothing. So I think you're just getting the numbers backwards. Do it. Let's look at them. Okay, so can we go back to your notes? We have 3 questions left. Okay? Next one. Yes, we do. We want to do it. Okay. New type of question. Find the value of k to make f of x continuous for f of x equals kx squared and 2x plus k. less than or equal to 2 on top, greater than 2 on bottom. Okay, so you guys are smart. What do? Think about it. I want to make it continuous, and I need to solve for k. What does this top chunk represent? The left limit. What does this bottom chunk represent? Right limit. For it to be continuous, what do those chunks have to be? Equal. When do they have to be equal at? 2. So you're going to set both sides equal, plug in x equals 2, k will be the only unknown left, and then you'll solve. Okay? So, let's do it. You would have kx squared, that's my left limit, needs to be equal to 2x plus k, that's my right limit, so this is, we'll say left limit, equal to right limit. But then remember, they don't have to be equal everywhere, they just have to be equal at that one point. So then I'm going to plug in x equals 2. So what is x squared if x is 2? So this is really a 4k, are we fine with that? Okay, then I'm taking my 2 here, plugging it in. 2 times 2 is 4 plus k. Now what? Subtract the k, bring the baby to the mama. Y'all do that? No? You move the littler one? Math models? Nobody? Okay, so k's crossed out. What's 4k minus a k? Then 3k is 4. Divide by 3, k is 4/3. Good. You ready to try one? What is that? Alright, we got 2 more left. And then maybe we'll have time to do one off the homework. This is when you're trying to find a constant to make it continuous. So first half of your notes, you were figuring out whether it was continuous or not. Second half of the notes, you're finding a constant that will make it continuous. That's your difference. Okay, ready? Next question. I'll just put it up here. Okay, write it down if you haven't already. Okay, that one right there. Same instructions. I want you to make it continuous and find the value of a. Okay, so I'm going to turn my paper over in a second, but some of y'all look like you're still copying. So, question is, if that's my piecewise, what value of a is going to make it continuous? I'll give you maybe like a minute and a half. And if you do it, you get a Whopper. Can't eat. What? And or I have a Dum Dum. You can. Fancy over here. Okay, your answer, the top and bottom should both be either a perfect cube or a perfect square. That's your hint. Okay? So it was x plus 11 on top. For x less than negative 4. And it was ax squared plus 4x plus 5 for greater than negative 4. Find a so that f is continuous. Okay, what are you doing? You know how to do it? You're doing it, yes? You're close. You messed up somewhere. The top and bottom should be a fraction. One should be a perfect cube. One should be a perfect square. Close.
Oh, wait.
Yes.
Do I get a Dum Dum then?
Gotta unlock them. Gotta lock up my Dum Dums around here.
Not even close.
You can do it. Come receive your dum-dum. Oh, it's really close. Really close.
Dum-dum.
Which one?
So many options.
I thought I
No.
I'll put the page over.
Are some of our algebra skills not so good? Okay, you should have x plus 11. Okay, okay, okay. And then you know you're plugging in -4. That's the plan, right? We're good on that?
Yes.
Okay, keep going. You can do it. I believe in you.
Okay, why, you're dividing by the wrong side. You're right.
Oh, so, oh.
You goof.
Well,
Missing some blood in your brain after
Wait, so
your
he had a clip?
transfusion.
that's fine.
No broken kid.
Thank you.
You're welcome.
Anybody getting it? Chris, what'd you get? Oh,
Yeah? I don't know. What are you doing?
What'd you get?
Yeah.
What?
This is easy. I get to do math for reward. I don't know how to do this.
Where did
but
you
I don't know
decide?
what I'm doing.
Check where you're equals. You're really, really close.
Said what?
And then you have
Simplify
to
it.
simplify.
yup, 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 yup.
It's a matter of eight.
Yup,
It's late now.
yup, that's it.
Oh, that's why.
Okay, so,
Everything that's up there.
it should have been,
That's what I got.
yeah? Oh. Okay, yeah, let's do it. So what's negative, then we're gonna do one more after this. So if you didn't get that one, maybe you'll get the next one.
70.
Okay, hopefully you wrote it out. Okay, what's -4 plus 11 on this side?
Kevin.
Okay, what's -4 squared? 16a minus 16 plus 5. Combine these guys.
Oh.
So it'd be -11. Then how do you get rid of -11?
Add.
Plus it across. What is 7 plus 11? 18 equals 16a. What do I do last?
Divide.
Divide by who's in front of the a, which was a 16. Okay, and then 18 over 16 can reduce, both divide by 2, 9 over 8. Perfect square, 9. Perfect cube, 8.
Yeah.
Yeah? Good?
Yeah.
Okay, one more. Last one. The last one, right there.
Oh, it's 3.
Ooh. Okay, write it down and then think about it. What could you do?
You need some help? I think you need some help, bro. Yeah.
I need some help.
You help. Jordan, do you need some help?
With what?
Nah.
Oh no.
I can help you.
Thank you so much for that offer, though.
Oh my goodness. Anything for a dum-dum.
Are you calling me a dum-dum or saying you want a sucker? Okay, so do it. What do you do?
Hey, bro.
What could you do? There's 3 parts instead of only 2 parts.
You find a number.
Okay, we're not gonna just guess, as some of you like to do.
Yeah, man, I think I
Can
know.
you do the top and the bottom?
Okay.
That line is funny.
Okay, so let's just talk ideas.
Oh,
Oh, one lower, so I'm negative 1.
When should these be equal? At what x?
Negative 1.
When should these be equal?
2.
2. So if it's so go back, think back to algebra 1. A system of equations is when you're looking for 2 unknowns, m and k, But in order to solve a system of equations with two unknowns, you need two equations. So these two will be equal at their common value,
Oh.
and then these two will be equal at their common
So there's two
value.
solutions?
Do it. Well, you're going to get an m and a k.
So,
Oh,
But the
yep.
bottom one is not even two.
So try it.
Are you-
Set these equal, plug in -1. Set these equal, plug in 2. You can do it.
wait, M and a K?
So see the m and the k?
No, that's a warning.
Huh?
That's a warning.
Okay, I'll give you some more. Okay.
No. I think
You sure? I love to help.
we need some help. Not me.
Okay. All right. So this is what I mean. You're gonna let 2x cubed plus x plus 7 be equal to mx plus 3 plus k. Then you're gonna plug in x equals -1. That's gonna be one side. After I set these two chunks equal to each other and 7, -1, I'm going to set this middle chunk also equal to this bottom chunk. And I will plug in what there? 2. Because that's the break point between the middle chunk and the bottom chunk. So I'm going to have this. And I'm going to plug in 2. Your answers should both be fractions. So let's kind of just work down this side. -1 cubed, what's that? -1 times 2.
-2.
So that's a -2. Then I have plus, that's a -1. Then a plus 7. Let's just combine that one side. 4. This is -3 plus 7, which is 4. Good so far?
Yeah.
Other side, I have a -1 going in for my x. -1 plus 3 is 2, so that's a 2m plus k. So far, so good?
Yeah.
2m plus k. Then we get to a point where we can't keep solving, so pause. Come to the other side. What is x for this equation? 2. So m times 2 plus 3 is 5m plus k. Over here, 2 squared is how many? 4 plus 5, which is 9. Okay, what do you do from here? You took algebra 1.
You
Substitution.
Yeah.
Okay, now, can I substitute if neither equation is solved? No. So what we're going to do is I'm going to solve this one for k, and then I'm going to sub into the other one. Now, could you solve that one for k and sub in here? Sure, doesn't matter.
Totally fine.
Okay, totally fine. That's right. So k equals what if I solve this one? Okay, bring my 2m over. It's a 4 minus 2m. Then I'm going to plug that in here. So I'll have 5m plus, and then when I get to my k, I'm putting a 4 minus 2m in that spot. Now, why is this better? Now I have all m's. I can combine like terms and continue to solve. Versus with k's and m's, you get kind of stuck. So 5m minus 2m, what do we get there? 3m. 3m plus 4 is 9. What's my next step?
Subtract 4.
Okay, subtract the 4.
Divide by 3.
Good. So 3m is going to give me 4's cross out, that's a 5. Divide by 3, I get 5/3. So far, so good? Okay, on the other side, now that I know that m is 5/3, I still need k, but I know what k equals in terms of m. So I'm going to take my 5/3, pop it in right there. I want you to get it down to a single fraction. Okay, give it a shot. If you don't remember, try to remember, and then I'll do it for you in a couple seconds. I think it comes out to be, anybody got it?
2 over
It
3.
is 2/3. If you got that, shh, celebrate quietly. If you didn't, k fractions, what's 2 over 1 times 5 over 3 times the tops times the bottoms?
10 over 3.
Okay, that's 10/3. So I have 4 minus 10/3, because that's like a 2 over 1. You times the tops and get a 10, times the bottoms and get a 3. Now, 4 is no good if I need thirds. So I'm going to times it by 3 over 3. What is 4 times 3? 12 thirds. So then I have 12 thirds minus 10 thirds. Now I have a common denominator. 12 thirds take away 10 thirds is 2 thirds. Good?
Awesome.
So K is 2 thirds. Okay, so this step I did not write down, but you would times by 3 over 3 to turn that into a common denominator. Yep.
Yeah.
You're done. Good.
Wait, so how do you know for a second one, 202, because up there, it's not X?
Because the break point between the middle chunk and the bottom chunk is 2. So look at in your domain, 2 is what these both had in common, versus negative 1 is what top and middle had in common. Okay, you are doing that on the back of the homework if you want to just look at it real quick. You don't probably have time to do it. But 6, 7, 8, 9, all of those, you're finding a letter. And then I'll give you the letter that we did in the other class. 8 should come out to 3 halves. So if you want to write that down, 8 should be 3 halves. If you don't get that, then you did it wrong. Okay?
Is this homework for this Friday?
It's not due to